What's up? I'm AJ and welcome back to Gen Z Garage. In the last video, we removed the cylinder head from the engine as well as some other parts which I don't have here right now. In this video, we're going to be taking apart the cylinder head and putting the pieces in this, and we're going to be disassembling the bottom half of the engine. But before we begin, I'd like to tell you what this is from last week's trivia question.
Good evening. This fantastic device that I present to you here today is what's referred to as a tachometer filter. The one I dispatched from my Fiero was so badly bungled that I chose not to take a picture of it in the previous video. Instead, I've carefully selected an image from Rodney Dickman. Rodney Dickman offers OEM replacement tachometer filters in the original style, configuration, color, and connector. You can get one just like this from rodneydickman.com. It's a fantastic piece of kit.
Congratulations to Emmanuel Martinez for being the first to answer the challenge. Thank you everyone for playing.
Before we begin the engine teardown, let's discuss first what the tachometer filter does and why we use one in the Fiero. All 1984 through 1988 distributor-driven Fieros use what's called a tachometer signal filter. This filter does not affect your ignition system, but instead simply filters the outgoing signal to the tachometer. Our Fieros use a digital tachometer rather than a mechanically driven one, which measures the number of pulses coming off the ignition coil. If the pulses coming from the ignition system are too noisy, such as from voltage spikes and signal interference, the tachometer can display improperly. It can even cause the needles to float at certain RPMs. As shown in the diagram to the right, GM's tachometer filter is essentially a capacitator which smooths out the signal for the gauge, which along with a resistor that protects the tachometer's board from higher voltage spikes. Thank you for watching AJ's Masterpiece Garage. And now, let's get down to business.
I start by transferring the push rods from my makeshift numbering box to my new drivetrain disassembly tray. Although I will likely be replacing most of these components, it's important that everything is stored in proper order. Should I need to reuse any of these parts, I don't want to combine parts that weren't originally worn together. This can cause unnecessary wear, which could lead to premature failure. I store the rocker studs and rocker arms together in each of the provided slots. At the very least, I'll likely be reusing these. I also saved the pushrod guides, as I'll probably be reusing these as well. They take very little wear and generally do not need to be replaced. I'll also strip the block of any sensors, starting with the coolant temperature sending unit, followed by the temperature sensor. I'll be replacing both of these. And finally, I move on to the spark plugs. Next, I turn my attention to the short block, and I'll start by removing the oil pan. This is held in place by 16 10mm bolts, and apparently gobs of RTV sealant. Next, I remove the crank pulley. This is held in place by 3 13mm bolts. If I convert to the 87 belt system, I'll be replacing this. For now, I need to take care not to damage it. A little support from a rubber mallet helps to liberate it. And then the flywheel. I'll probably be replacing this as it has stress cracks all over it. I then move back to the front and remove the crank bolt, and then the crank hub. Next, I remove the oil pump and pickup. I'll be replacing it with a higher output oil pump to ensure I'm getting good oil pressure and good cylinder wall lubrication. With that out of the way, I clean the rod caps, Before I can remove the pistons, I need to make sure I can keep track of where they were in the engine. I use my Dremel tool to etch the cylinder number into the back of each. I can now begin removing the rod caps, which is held on by two 13mm nuts each. Once removed, I cover the studs with protective covers to make sure I don't damage the journals as I remove them. Normally, you'd use a ridge grinder to remove the cylinder wall ridge to protect the rings, but I plan on replacing all of it anyway. So a little extra persuasion is all that's needed to get the piston to come out. With the piston removed, I'll cover the crank journal with a shop rag, just to be on the safe side. I move on to the next cylinder, following the same process I took with the previous. And then cylinder 3, and finally, cylinder 4. I move back to the front and tackle the timing cover. This is held in place by 8 10mm bolts and more RTV sealant. This plate covers the mechanical timing gears that connect the crank to the camshaft. With the plate removed, I start removing the main caps that hold the crank. Each one is numbered, so I don't need to keep track. They're on tight, so I use a rubber mallet to carefully break them loose. With the last one out, I can then remove the rear main seal. And with that, I lift the crank up and off the engine. I'll remove the cam later, but first need to remove the roller lifters. The galley plate is held in place by 4 studs attached to brackets. I'll need to reuse these, so I carefully remove them. I then remove the lifters.
Thanks for watching. In this video, we disassembled the cylinder head and the bottom end of the engine. In the next video, we're going to be taking it to the machine shop to get it repaired. But before you go, I'd like you to tell me what this is in the comments below. Thanks for watching.
This year, you can break away. Right now is the time. Right now, why not break away? Break away in a Firebird. Break away in a Grand Prix. Break away in a GTO. Break away in a White Dragon Pontiac. 'Cause the White Dragon Pontiac is the breakaway car this year. Pontiac, get a White Dragon Pontiac. Get a White Dragon Pontiac. It's the breakaway car.